Good morning, everyone, and welcome to the November PHDV webinar. Today's presenter is Dr. Anastasia Krainyk. She'll be talking to us about integrating human dimensions, objectives, and landscape conservation planning, the policy implications. Anna, whenever you're ready, please be free to go ahead.
Thank you. Good morning, everyone. I hope you can all hear me okay. It's a really great honor to be here today. Thank you for fitting me into your November agenda. I'm really excited to tell you all a little bit about these ongoing projects of integrating human dimensions objectives and landscape conservation planning, and some of the possible policy and funding implications from these projects. So I would really like to first acknowledge all of my collaborators. This is a group of people that have participated extensively in the development of the models I'll talk about today. And my goal is really to speak to you all about frameworks that we have developed over the past 3 years, which focus on spatial integration of social objectives in waterfowl conservation planning, and also some ways that our models are being used to make real decisions about funding. So with that, let's see. Okay. I'm sure that this group no doubt understands the complexity of decisions related to natural resource management and conservation. There are more often than not numerous objectives or targets that we are trying to achieve at the same time. There are generally many partners and stakeholders that will be affected by these decisions. Additionally, data availability is variable. For example, some regions in North America have sophisticated modeling of waterfowl distributions and densities, while others have relatively few data or do not have the capacity to develop such spatial models. So we are also often dealing with understanding uncertainties and risks. And whenever decisions are made, we rely on our understanding of these hypothesized relationships between habitats and species. And there are always risks attributed to our predictions of future events. So finally, there can be major differences between goals and values regionally as well. It's really an unspoken understanding that we as managers and conservationists will never have enough resources to protect, restore, enhance, or manage everything. This is why natural resource management decisions need to be made with an understanding of sometimes quite difficult trade-offs in costs and benefits. Waterfowl and waterfowl habitat conservation and management is one of the oldest and most successful adaptive management frameworks in North America. And so waterfowl managers and decision makers are already well familiar with the complexity of management and conservation decisions in Canada, US, and Mexico. Let's see. The North American Waterfowl Management Plan largely governs the transnational preservation of waterfowl species, their habitats, and those that rely on ducks and geese for sport and subsistence hunting. But since the publication of the first North American Waterfowl Management Plan in 1986, one of the major components, the spatially explicit depiction of areas in North America important to waterfowl, has really evolved. Early versions of the map were largely based on expert knowledge, research, and some breeding waterfowl surveys. In '94 and in '98, the expansion in important to waterfowl was largely a result of socio-political changes that came with the increase in the number of joint ventures in North America. But by 2004, geospatial tools were more readily available and utilized, which led to new insights and better mapping capabilities of waterfowl distribution and densities. However, after the release of the 2004 map, several of the joint ventures identified some boundary errors. And the 2012 map revision was developed by a committee of the NSST to correct these boundary errors or to better justify inclusion of areas with empirical data from specific joint ventures. So by this time, by 2012, many of the joint ventures had initiated or already completed quite impressive projects on mapping and modeling waterfowl distributions and abundances using geospatial techniques. And regional conservation had, in general, become much more strategic. However, during the process of refining the 2004 map and developing the 2012 map, the MAP committee, as it was called, identified still many shortcomings and put forward recommendations for the next iteration of this spatial product of NAWAMP. The major concerns of the mapping committee included not being able to develop the universal criteria for area inclusion in a NAWAMP map. In the report, they also stated that quality and reliability of waterfowl varied among regions, and that given the subjectivity in its development and refinement, the NAWAMP map had limited ability to inform conservation decisions and investments. So in addition to these concerns, the 2012 NAWAMP added a set of new objectives, human dimensions objectives. And although many regional managers had already been taking social values and needs into consideration informally in their waterfowl habitat management initiatives, this revision really solidified the importance of explicitly integrating the services provided to people from waterfowl habitat delivery initiatives. So this social dimension was clearly missing from the 2012 MAP revision. And the MAP committee at that time included recommendations for the integration of social objectives. So based on the recommendations of the 2012 mapping committee, the Priority Landscapes Committee was established in 2015 by the NAWAMP Science Support Team and the Interim Integration Committee. The function of this Priority Landscapes Committee was to oversee the development of a new framework for identifying geographies of continental significance to waterfowl and people. There was a strong emphasis on developing a framework that was science-based, transparent, repeatable, so that it could be updated every time NAWAMP was revised, and scalable. Additionally, the new framework needed to integrate the biological and the social objectives outlined in the 2012 map. So as you may have guessed, this is a multi-objective, multi-stakeholder, multi-data problem that can get very complex and hairy very quickly. So the Priority Landscapes Committee adopted the structured decision-making approach to our model development. And this SDM, structured decision-making, is based in decision theory and risk analysis. It encompasses a simple set of concepts and helpful steps rather than a rigidly prescribed approach to problem solving. Key SDM concepts include making decisions based on clearly articulated fundamental objectives, dealing explicitly with uncertainty and risk, and responding transparently to legal mandates and public preferences or values in decision making. So in effect, SDM integrates science and policy explicitly. PROACT is a commonly used acronym used to describe the discrete collaborative steps that are taken to reach a specific decision. And here you can see this PROACT wheel that characterizes structured decision. In structured decision-making, tools like multi-attribute utility theory can help with the analytical steps of the trade-off analysis. So we're talking about here, the analytical optimization and trade-off analysis. Multi-attribute utility theory is most applicable to solving problems that are characterized as choice among alternatives. It follows the same formula for defining objectives, determining alternatives, determining consequences, and then doing an analysis to determine trade-offs among specific objectives. The concepts of multi-attribute utility theory govern what we call spatial value modeling. So I'll just give a very quick course explanation of what a spatial value model is, as this is quite important for the remainder of my talk. So there are 4 components to a value model. The first is objectives. So identifying the things that matter to a decision maker is really the key first step. So next, we identify performance measures, which are specific metrics that can be used for consistently estimating and reporting the anticipated consequences of different management alternatives with respect to each of the individual objectives. Value functions are used to standardize the performance measures, so values related to diverse objectives like dollars or density for ducks or kilograms per hectare fertilizer could be compared on the same scale. And finally, we define weights, which are subjective because they describe a decision maker, could be a regional decision maker, could be a national decision maker, values one objective over another. So once these elements have been identified and objectives mapped, we use the additive multi-attribute preference function to determine an overall score at the pixel scale and produce an aggregated mixed objectives model, which includes both social and biological objectives. So I'm actually not going to get into the details of how each biological and social objective was selected by the committee, but here's the summary of all 29 objectives that were included in the model, their performance measures, and the weights that were assigned to each. So objectives were determined through workshops, speaking with experts, and dissecting decisions that are made by waterfowl habitat managers. We settled on several priority species, and the rest were lumped into guilds for our biological objectives. Our decisions for inclusion of specific human dimensions objectives were largely influenced by human dimensions working group research and the results from their discrete choice modeling. The performance measures were also determined through a collaborative discussion and workshops. And we chose performance measures that were available at the continental scale and were relatively consistent. So that was really important to getting a fluid continental map. And a lot of times that limited our selection of performance measures because it had to be at least available at the continental scale. So a lot of time was also spent discussing the distribution of weights, and the Priority Landscapes Committee felt that we didn't really have sufficient information at regional scales to make informed decisions about variation in weights. At this time, when we were building this model, we didn't have consistent participation from every single joint venture to be able to elicit appropriate weights regionally. So we actually adopted an equal weighting approach for the continental model, but I will come back to that in a little bit. So the framework, the model development and consisted of a family of spatial maps were all published in this 2019 USGS report. The spatial products were maps that depicted geographies of greatest continental significance to waterfowl and people based on different combinations of objectives. And at this time, we also presented, or at that time when it was published, we also presented our results and the map products at several conferences and meetings, really designed to communicate the advances in conservation planning to decision making and to the larger waterfowl management community overall. Although the work was received with excitement and interest, there were still several limitations to our model. I'll discuss these in a little bit. So here we're just talking about the continental model products. So our final products did include 5 models, which we refer to as our family of maps. So here are just 3 of those models. The first represents our mixed objectives model that includes only biological objectives, so only waterfowl densities during the breeding season and waterfowl duck use days during the non-breeding seasons for those 9 species groups that were shown in the table a few slides ago. The second includes only the social objectives. So this one in the middle includes only the social objectives. And the third product included all 29 biological and social objectives. So the key takeaway from this slide are the spatial shifts in hotspots due to changes in objectives and weights. Most distinct are regions like Alaska that show up as hotspots when we care only about biological objectives, but are relatively cool spots when we care only about social or human dimensions objectives. Northern and central and southeast US and the Midwest. So some of these shifts are attributed to the inclusion of social objectives, and I'll get into this a little more in a few slides. The current continental model that I've just been describing has limitations for application at the regional scale for several reasons. So firstly, all 29 objectives were used in the final model regardless of regional discrepancies. Additionally, a default weighting scheme was assigned where each of the objectives received the same weight. And although the scaling of the model to smaller regional boundaries is possible with the data and the framework that's already been published, it does take a considerable amount of time and does require personnel with GIS expertise. So it's not easily achievable by every single joint venture that perhaps do not have the capacity or the time to commit to this type of project. So the Priority Landscapes Committee cautioned the use of the continental model to make regional management decisions, but they also proposed the development of a user interface that would allow for more flexibility and aid regional managers in creating their own tailored spatial products. A general call for the development of a tool to aid in this regional application of the model led to a proposal last year, which was eventually funded this past February in 2020. And the regional Priority Landscapes Committee was established. So it's essentially a lot of the same people, but as the continental model was developed by the Priority Landscapes Committee, we called ourselves a regional Priority Landscapes Committee for this second portion. And their function was to oversee the development of the user interface that would allow scalability of the continental product. Again, we adopted the same approach as I've already described, following the steps of structured decision-making and initiating our work by basically taking apart the continental model. So the important point I want to make is that the continental model is essentially a pixelated landscape, where every pixel has 29 values, one for each of the objectives included in the model. So it's really this matrix of values that allows us to develop regional models. And so we first, there's a really brief slide about the methods, but we first overlaid a 10 by 10 kilometer grid, which we called the reference grid, and we extracted 29 values to each of the unique grid cells. Next, we identified a set of unique grid cells that correspond to each of the spatial scales we were actually interested in. So this, in effect, created what we call a type of dictionary, which can query the unique grid list based on the scale that is chosen by the model user. And as you can see here, we had exactly 193 total spatial scales that we were interested in. So we included bird conservation regions, joint ventures, of course, but also states and Canadian provinces, different types of scales to choose from. We used Visual Basic Applications code in Excel to actually code the user interface, and we were able to test our model with several examples already. I believe the model's already been completed for 2 months, and our committee's been trying to break it, test it, create maps, and mess around with it. So at this time, the Regional Priority Landscapes Committee has, like I mentioned, produced the user interface coded in Excel. We also produced a user manual that guides the model user through the step-by-step process, and a shapefile reference grid, which can be used for visualizing the model. So basically creating the pixelated map products. And Additionally, we have initiated 2 pilot studies. The pilot studies will use the interface and outside spatial data sources to develop tailored regional spatial products that can aid habitat management decisions on the ground. And right now we are almost finished with the Eastern Habitat Joint Venture pilot study. The Eastern Habitat Joint Venture really currently didn't have any type of landscape prioritization models, and so when we approached them to be our pilot, they did seem excited, and it's an opportunity to develop something without a great amount of resources being devoted from the Eastern Habitat JV to this type of project. And the Upper Mist JV is our next pilot study, which we really haven't started yet. So here are just some of the examples of the regional models that we have already run to test the user interface and to explore the flexibility in objective weight assignment and how these affect shifts in spatial prioritization. From our preliminary test, the Regional Priority Landscapes Committee concluded that the model allows for quite extensive flexibility, especially in scale selection, objective selection, and weight assignment. It's relatively easy to use if you're just following the user manual. The user manual is about 5 pages or 6 pages long. And importantly, it can be used for rapid scenario exploration and developing regional products that aid in the decision-making processes. However, we do caution that eventually when we do publish this model, weight elicitation is extremely important. Changes in weights and objectives can have major shifts on landscape prioritization. And so we do talk with our committee a lot about those kind of situations, and we do talk about specific formal elicitation processes that should be available to model users. So just yesterday or 2 days ago, I put together a really quick example of the Prairie Habitat joint venture, since I think it might be relevant. And of course, I'm not a regional expert in this part of the country, in this part of Canada. So I really didn't spend a great deal of time thinking through the weights that I was putting on the specific objectives. However, the point was to illustrate that a map with weights biased towards biological objectives, over 80% of the weight is on biological objectives, looks quite different from a spatial prioritization that puts most of the emphasis on social or human dimensions objectives. The map on the right is over 80% of the weight is on human dimensions objectives. And so you can see some of these major shifts already in the landscape prioritization. And these types of exploratory maps or examples can help decision makers start exploring scenarios, start understanding why shifts are happening when we include social objectives, and also to start branching out to new partners. Perhaps there are conservation partners out there that are not necessarily focused on waterfowl, but are focused on things like open spaces, providing birding habitat for birders. So waterfowl managers can start working with some of these other partners that deal more with ecosystem services and things that are of more interest to the general public. This is another image of a close-up. This is the southwest of the Prairie Habitat JV. And again, it's the same map with the one on the left being focused on biological objectives only, and the one on the right being focused on social objectives only. And so when it comes to making decisions, we have to start understanding what a parcel of land, for example, in this area, is going to contribute towards benefits in terms of biological objectives, or how is it going to contribute to benefits in human dimensions objectives arena. So I'm gonna switch gears a bit here. And so what I spoke about in the past half an hour or so has really been mostly about the first 2 projects that we've been talking about continental prioritization and regional prioritization, or the scaling down of the continental model. However, there are real decisions on the ground, and what really happens when a decision maker is presented with alternatives for something like investment of funds. This is where we have to consider the subsequent steps in the SDM adaptive management wheel and start talking about trade-offs, actual analysis, optimization, and so on. So as I mentioned, the spatial value model cannot provide a recommended decision because there are really no alternatives and no explicit problem defined. A prioritization model only prioritizes what is currently available on the landscape. But it can provide the information that is used to build decision support tools. So each pixel, again, has these 29 associated values, one for each of the objective. And the model was made up of layers which contain the reference information. So it's this information that'll allow us to build decision support tools when a problem is actually defined and when a decision maker is presented with alternatives. The National Wildlife Refuge System actually has such a decision and alternatives to consider in order to address their annual funding problem. So the NWRS exceeds over 60 million hectares and includes more than 550 refuges. It's a national program in the United States, and it grows annually through piecemeal acquisitions and easements. Generally, two funds are used for these acquisitions. So there's the Land and Water Conservation Fund and the Migratory Bird Conservation Fund. And we developed a decision support tool that focused strictly on the funding decision under the Migratory Bird Conservation Fund, which has an annual budget of approximately $20 million. It was established in 1934 and is funded largely through duck stamp sales, sales of ammunition and hunting equipment. So we worked with representatives from the National Wildlife Refuge System. We defined an actual decision context. So here's the abbreviated short version of our decision problem with the added constraints on budget and the fact that it is an annually recurring decision. And so currently, the National Wildlife Refuge System uses the Targeted Resource Acquisition tool, known as TRACT, which is basically a complex constructed scale for refuge parcels that have been submitted for purchase consideration. The Land and Water Conservation Fund distribution is based on the ranks for several categories. So there are several these constructed scales for each parcel of land. But the Migratory Bird Conservation Fund eligibility is only considered by the waterfowl score. And so the current process under MBCF also considers cost per hectare of a parcel and the regional priority rank, which is a rank assigned to the submitted parcel by the regional stakeholders. But currently, there's no social objectives that are explicitly included in the ranking process, and there are no trade-offs among the three ranking criteria. But most importantly, there is also no optimization and no aggregation rule for combining ranking criteria. So it is quite, there's quite a lot of, in-person and subjective decision-making involved in putting together a portfolio, even under the current tracked constructed scale. So this slide shows the current constructed ranking flow diagram that is used to assign a waterfowl score to each parcel submitted for MBCF funding. And it may be a little bit difficult to see, but you'll notice that the criteria are somewhat broad and only one waterfowl species is considered at a time, which the rank, with the rank increasing by one tier if there is a second species that meets that criteria. So that's, here is if there's a second species that meets that criteria, the rank increases. But what about, this a fourth species, a third and a fourth species? And what about the trade-offs among those species? And more importantly, what about the trade-offs with social objectives? So in short, the NWRS has this problem of making portfolios from a discrete set of submitted parcels, which optimizes the benefits they gain from the budget that they have available annually. So We took on the SDM approach again and worked with our committee and the representatives from the National Wildlife Refuge System in a collaborative workshopping format. We again identified objectives, selected performance measures, defined value functions, and elicited weights, all in a collaborative process. Our alternatives, or the discrete set of parcels, were submitted for purchase in 2019 cycle, so we used that as our alternatives. And everything was done, again, in this collaborative process. Only the model building was done by myself. So after discussion with our NWRS representatives and the committee, it became apparent that they actually cared about many more things than just cost per hectare and regional rank. So we defined 23 objectives. And the performance measures for these objectives came from several different sources. And here is where the spatial value model that I described before came in use. We extracted the values for each of the biological objectives for each parcel of land from our spatial layers. Other performance measures were calculated by hand for each parcel, and the social objectives performance measures came from open source EPA Environmental Atlas. So the weights here are assigned based on discussion with our NWRS representatives, but again, there is considerable flexibility as possible new policy mandates and possible new mandates change over the years, or as the decision makers want to change the weighting scheme to put more emphasis on social objectives or on a particular species, they can do so. This is really busy. It's just a screenshot of the matrix in the Excel portfolio optimization program. And the important parts here is that at the top are our 23 objectives, and on the left are our 40 discrete refuge parcels. In the middle are the corresponding values of performance measures. So there's also a column with the cost of each parcel on the far right here. This is important. Oh, apologies. This is important because in the decision problem, we have a specific budget that we cannot exceed. So the cost column becomes quite important in optimization. So objective performance measures values that were in the center of the matrix are normalized using the specific value functions and weighted according to the assigned weights. Basically the model operator or the decision maker, and then the decision maker inputs the required cost constraint, and the optimization is run through the solver in Excel. The optimization essentially has two components: to maximize the total conservation benefit of the portfolio and to minimize or stay within the cost constraint. And a decision variable is then assigned to each parcel. 1 means include the parcel in the portfolio for purchase, and 0 means do not include. So this, I know this is kind of a lot, but the point is that we are combining biological and social objectives, but we are also determining a portfolio of the best parcels to purchase given our cost constraint while trying to maximize the conservation benefit that we'll gain from that portfolio. So that's what all these equations mean. That's all they mean. So we ran several portfolios with different cost constraints and mapped them on a Pareto efficiency frontier. We also actually mapped the portfolios that were created by the National Wildlife Refuge System using the tracked approach. So generally speaking, as budget increases or as the cost constraint increases, the total portfolio benefit also increases, and that seems obvious. The more money you have, the more parcels you're able to purchase, the more benefits you gain. In most cases, this generally continues until a plateau is reached, and at the shoulder of that plateau is where the best investment portfolios are, meaning that's where decision makers will get the best bang for their buck. And as you could see here in this Pareto efficiency frontier, the 3 portfolios that were created using the 3 criteria from the tracked approach, the current National Wildlife Refuge System approach, do fall below the Pareto efficiency frontier. What this really means is that they're essentially spending the same amount of money, but they are leaving conservation benefit, so to speak, on the table. So they could be gaining a lot more conservation benefit if they actually ran the constraint optimization. and included social objectives. And the bar graph on the right is a visual depiction of the portfolio benefits broken down by objectives. These types of visual products can be very useful in communicating decisions and justifying choices. They're also provide transparency and increase confidence that the best decisions to solve the problem are being made, so they can be effective communication tools with your decision makers or stakeholders. And lastly, we also throughout the presentation about how important weight assignments are to objectives. This is just an illustration of one of the objectives, the parcel area, and the shift in weight on this objective determines which portfolio is the non-dominated portfolio. So, for example, when the weight is 0.8 or more, basically 80% on the objective, the optimal portfolio is actually A, which was one of the NWRS portfolios created using their current methods. So these types of sensitivity analysis can help us understand which objectives are really sensitive to changes in weights, and also help highlight again the importance of proper understanding of decision maker values and regional elicitation of weights before making any type of spatial prioritization product or optimization decision support tools. And so this is just a really quick basic conclusion slides, but the point of these three projects that I've described is that all three of them explicitly actually integrate social objectives into conservation planning and finance. All three were collaborative, which generally brings everyone to the table. It encourages understanding, encourages buy-in, and increases understanding, and therefore reduces uncertainty if people were to start using these types of models. All of three models were based on the best available data that we had at the time. Obviously, new data always becomes available, and that's why point number 4 is important. It's updatable. The framework we provide can be easily updated as new spatial data or research data becomes available in the future. And it's transparent. All of our step-by-step process and model development was published as supplementary information in our reports and will be in the future for the National Wildlife Refuge System optimization portfolio, so that decision makers and users of models can have more confidence again. But I think most importantly, and I saved this one for last, it's flexible. So there was a lot of concerns with the continental model that regional decision makers were not going to be able to tailor to their specific needs or to their specific region. And the user interface has made that has allowed for that flexibility, flexibility in selecting an appropriate scale, flexibility in selecting an appropriate objectives, and flexibility in assigning weights. However, we as a committee, we always caution when we give these talks that it's great to have exploratory tours like that where you can make many maps quickly and compare them. But any type of product that will eventually be used by decision makers still needs to go through a collaborative elicitation process with either a JV management board, and really discuss which objectives should be included, why, and which weights should be assigned and why. Because the products, as you can see, will determine where landscapes are prioritized. So I think that's all for me, and there's my contact information if any of you want to ask me questions later. But thank you very much. I really appreciate the opportunity to share our work, and I know my group is also appreciative that we're able to share a little bit of what we've been doing in the past 3 years.
Great, thank you, Anna. If you do have any questions, please go ahead and either use the raise your hand or type your questions into the chat box. Great, thanks. Katie, you can go ahead and either type your question or you can ask Anna directly.
Great, thank you. Anna, that was a really interesting, very much. I was just interested in whether you had a view on how complex or how many different objectives model could take, and whether there's a kind of optimum number to include, or whether actually it's kind of the sky's the limit in terms of including the kinds of information that you want.
I'm sorry, I actually am having a really hard time hearing you. Can you speak up just a little bit? I thought you were asking about objectives.
Sorry about that. I'll try again. Is that better?
Yes, much better. Thank you.
Oh, good. So thank you. That was a really interesting talk, and I found it really informative. I was just wondering, in terms of objectives, whether there's, you sort of imagine that there's a limit on the complexity of what you can put into the models. You know, whether there's kind of, you know, a recommended number of parameters that you'd want to include, or whether actually the sky's the limit in terms of, you know, the number of priorities that could go in.
Yeah, that's a great question. So, I mean, analytically speaking, there's really, you could put in quite a few objectives, right? 100 probably or more. But realistically speaking, you know, of course, there are many different objectives. Sometimes they're competing in terms of natural resource decision making, and that's understandable. And stakeholders or decision makers do want to include everything that they care about, and everything that, you know, they are concerned or have targets. However, as you increase the number of objectives more and more and more, each individual objectives become less and less important because the weight needs to be distributed, you know, divided more and more and more. So in essence, that there is this like sweet spot. And we found that even with 29 objectives continentally, variation in weight still affected prioritization quite a lot. I haven't gone beyond 29 objectives. Some of our other models there's about 8 or 10. And so those, you know, the fewer objectives you have, the more important an understanding of weight is. When you have quite a lot of objectives, weight is still important, but it will not influence change in prioritization as much. Does that make sense?
Yes, that's great. Thank you.
Mm-hmm.
Okay, it appears that there are no more pressing questions. If you do have questions, you can either feel free to contact myself or John, or as Anna said, you can contact her directly, and we'll get back to you with a response to her questions. Again, I would like to take this opportunity to thank Anna for her very interesting presentation today, and thank everybody for joining us. And we hope you join us for our next PHJV webinar.
Thank you all again. Thank you.